All right. Welcome back. Sorry about the slight delay. Um, so today I'm going to um talk about stacks, right? The stacks data structure. I'd done this before. I solved these questions before, but I completely, moved on to other topics. It's really difficult to do do 100 days of coding streams while you have a full-time job and so on. So today, for today's session, I'm going to keep it really simple. And like the past couple of days, I've been trying to make shorter videos, but I end up making it long anyway. So let's see. Today, I'm just going to go over stacks, talk about stacks, and relearn stacks, solve a couple of stack questions, and so on. Right. So, what do we have here? So here's a baseball game. Now, before we continue, I would like to explain what stacks are. So stacks are basically um, an array data structure. Oh, so these are the stuff I had from yesterday. So stacks are basically arrays, right? And in which we add items. So here's what here's a basic representation of a stack. Let's say we have an array like this, right? And then we add, like, say, one to this array. I'll call this array numbers, right? Numbers is equal to an array, and then we add, let's say, a value. So I will instantiate this, right? This is a stack. This is an empty stack. Empty stack, right? This is an empty stack, but um we can add items to this stack and remove items from the stack. Now, adding an item to the stack is done by appending an item to stack. And when you add an item to a stack, it means you are adding an item to the top of the stack. So stack have let me represent this with a different array. So our number array would look like this, right? After adding, let's say we add one to this array. Now this one will appear here and the array will look like this, right? And then let's say we add two again, so it will look like this, one and then two. Now every time we add an item to a stack, right, in other words an array, it means we're adding item to the top of the stack, right? So meaning every item we add, right, every last item we add will appear at the top of the stack. So the item at the top of the stack in this array now will be 2, right? It's this 2 here. It's at the top of the stack. So stack, we can operate LIFO operations on stack, right? Or we can, how do I say, we can apply, yes, apply LIFO operations on stack. What does that mean? It simply means last in, first out, right? So the last item to be added to the stack will be the first item to be removed. In other words, the last item added to a stack appears at the top of the stack. So let's see an example with this question. So we have and most of the times, right, we are simply going to be appending items to the stack and removing item from the stack, right? Adding an item to the stack takes O of 1 time complexity, which is a constant time. So we add items to a stack in constant time. Now removing an item from the stack will also take O of 1 because we are simply removing it from the top of the stack. In other words, from the end of the array. So let's see how we can solve this problem. So this is a Let's Code Easy. It's a baseball game, unusually baseball game. So let's see. You are keeping the scores of you are keeping the scores for a baseball game with strange rules. At the beginning of the game, you start with a record, with an empty record, sorry. At the beginning of the game, you start with an empty record. You are given a list of strings operations where operations I, right, is the ith operation you must apply to the record and is one of the following. So we have an integer x, sorry, we have an integer x, a plus, an integer x records a new score, right? The score of x. And a plus records a new score that is the sum of the previous two scores. D here is the record of a new score that is the double of the previous score, okay? C invalidates the previous score, removing it from the record. Return the sum of all record on the of all the scores on the record after applying all the following operations. Now, the test cases are generated such that the answer and all intermediate calculation fit into a 32-bit integer. Okay, this is not really, I mean, it's important. 32-bit integer and all operations are valid. Okay, so now let's see how we can perform or solve this question. Now, here is an example we are given, right? We are given an operations string, or a list of operation, a list of strings, right? Called operations, which is this input here. So our input is going to be an array. Now we have to iterate through the array and perform each one of these calculations. So I'll come here, right? Remove everything here and then paste it here like this. Okay, this is not good. Let me do this. Okay, this is better. So here's our array, right? And each one of these are records from our baseball game. So essentially what we are going to do is take each one of these records, right, and perform the recording accordingly, right? So what do I mean by that? We'll perform the operations based on these conditions here. Now x is an integer, right? X, so the first item in our input operations here is 5, right? So it is an integer. So what do we do with an integer? We record it as a new score. Now where do we record it? Now that's an interesting question, and that is where stacks come in, right? So since we are recording a new score, we'll create a new stack, right? I'll call this the score stack, right? This is the score stack, and set it to an array, right? This is going to be our empty array. So each time we iterate through each one of these operations here, we'll add the appropriate integer to our stack, or in other words, we'll add the record, the result to our score stack. So let's see, for 5 we'll add 5 to the score stack, so we'll have something like this. So we'll add 5 here. Now this is the same as the score stack here, so I'm just going to put it like this. So we'll add 5. Now when we see 2 again, we'll add 2 to the stack. But when we see C, what does C say? C says so C invalidates the previous score, removing it from the record. So this is our record, so we'll remove 2 from the score, right? We'll remove 2 because we are seeing C now. Let me remove. So we'll remove 2, and then we'll move on to the next item here, which is a D, right? Oh my god, sorry. Okay, sorry. Um, so here is 5, right? We added 5. So our next operation in this in the operations, right? Okay, yes. Our next operation in the operations array is a D. Now, what happens when we see a D? A D, records a new score, right? But the score is going to be the double of the previous score. So simply take the previous score from our score stack, right? This is our score stack, and we only have one item um in the score stack for now. So we'll take this previous item, or the topmost item in the stack, right? It is going to be 5, and then we record the double of this value here. Now the double of this value is going to be 10, so we add 10 to our stack, and then we move on. We see a plus, right? When we see a plus, what does a plus do? A plus adds a new score that is the sum of the previous two scores, right? So the previous two scores are 5 and 10. So we'll add 5 and 10 to our score stack again, and this is going to be 15. And at the end of the day, we will return the sum of all the scores on the record after applying all the operations. So the result of all of these scores here will simply run the sum on all of this on the score stack, on the score stack, right? Score stack, and this will give us this is 25 and this is 30, right? So we'll have 30 as our final result, which is what we have here, right? So I'll go ahead and implement this and show you how it is done. So first of all, I'd solved this question before, so it's quite easy for me now. But if you are seeing this for the first time, don't worry. I also struggle to understand it at first. So here's what we need to do. We'll need an array called in other words, our stack, right? So this is simply going to be I'll call this the score stack like this, and set it to an empty array. Now the next thing to do is to iterate through the operations array and take each one of these operators here and perform the operation and add those value to our score stack. So I'll say I'll call this operator, or let's say op, right? I can say operator, right? Operator for operator in operations, right? Now this will give me each one of the operators, right, in the operations array. So for in this case, I'll have 5, right? When I see a 5, right, we'll add that value to the score stack. When I see an integer, we'll add the integer to the score stack. When I see a plus, we'll add the previous two values. When I see a D, it means we want to double the value in the stack and then add it to as our score. Or when I see a C, we invalidate the previous score, which is removing the value from the stack. So here's what I need to do. I'll take the first. So let's start from the ones these operators, right? So let's say if the operator op is equal to a C, right? These are our operators. I can even create a stack, a dictionary, and look into the dictionary for all of these operations, but I don't know, it's not really necessary. This is very simple stuff. So in terms of the conditions, I'm not saying the question is simple, right? So let's go ahead and do this. So um I'll say I'm streaming. Sorry. So we have operator here. So when it's a C, right? When it's C, we'll remove the item, the previous score from our stack. So the previous score will be the topmost item in the stack. And the top item in the stack is the last item in the stack. And it's also the last item in an array. So we'll say, we'll take our score stack, right? Score stack dot pop. So we'll use pop, right? Which one are we popping, right? We'll pop the last item from the stack. I'm not sure. Let me use this, right? I must have forgotten something quickly. Let's say, I have an array of this, and I say operators dot pop, right? So what do we pop? If I do that, right, let me say print OPS and see what the answer is. Yeah, so it will remove the last item from the array. Good, I did not forget. So this will remove the last item from the array. So now if the operator is a D, so I'm going from bottom to top, then we'll double the previous score, right? So how do we get the previous score? Well, we'll simply do this. We'll say score, we'll double the score and then append it to the array. So score stack, right, dot append the score. So when we do pop like this, we'll remove the last item from the array, right, which is the previous one, dot pop, and then we'll double this times 2, right? When you do pop like this, it will return a value that you are popping from the array. So let me just print this again. Come on. Crikey. So let me remove this. Print pop. Yeah. So this will show plus and the remaining one. So you can see pop here. So we'll get the last value from the array, and then we'll double that value and append it to our stack, right? Now, if we see a plus, if the operator is now a plus, so if it's a plus, right, if it's a plus like this, then we'll simply append the sum of the previous two values, right? And this is how we can get the previous values in an array. I would say I'll call this first previous is going to be equal to score stack stack. So this will be the first one. Minus 1 will give us the first item, the last item in the array. And then I will do this for the second one as well. So first, and another simple way, we can just use a string slicing, right, to take the previous two items from an array. Yeah, I think that will work. I'll prefer that. So I'll simply do this. I can say and we want the sum of those two, right? So we can say sum of, hold on, let me first of all get the previous two. So if I say ops, right, and I want to start from -1 and stop at I don't know, what would this give me? This will give me plus, right? So this will, hold on, yeah, so this will give me the last two items, right? And then I can sum them up. So if I had, let's say if I had 5 and 6, right? If I had 5 and 6, then I can do this. I can say sum 5 and 6, right? And this will give me 11. Now I just noticed that I'm just appending these items to the stack. And so whenever we add an item to a stack, we want it to be an integer, right? So instead of doing this like this, so I'll say score pop. So before appending, right, I'll just say int. I'll put it as an integer like this. Yep. And I'll do this for the second one. I'll say score stack append, right? Score stack append. Score stack append. So some. If I do int, if this was a string, right? Let's say 5 and 6. Oh, 5 and 6, and I say some. I'll say int of these two, right? I'm not sure this is going to work. Now it won't, because must be a string, right? Yeah, so it must be a string for us to do this. This would have been simpler. Anyways, it's not bad. So we can just, I'll just go ahead with the previous method by just I mean, this is good. So you can say append int. I'll say some. Okay, we don't need to do that. You can just say int of the score stack, the last one, or the topmost one, and the second one. So int. So we can do this plus, right? Since we are adding them together, this is just going to be a plus int of the score of the second one. I just copied this. There's no autocomplete here, so it's kind of slow to type everything out. So this will be 2. So yeah, so we add the sum of the previous two integers, right? And when it's just an integer, right? So the last condition is x an integer, right? Else I'll say I can put an else, right? Else, and instead of doing if like this, I can say else if, right? I can put else if here, and then I'll say else just do score stack append that item here. So append an integer of the operator op. Yeah, so here is what we have, and at the end of the day we want to return the sum of everything. So return sum, right, of everything in the score stack. So yep, so that's about it, and let's run this and see. Probably made some mistakes, I'm not sure. Yes, so unexpected. Yeah, so I didn't put this here. Okay, so let's go again. So you can see I used operator here and I used op there. Rookie mistake. So what is going on here? Now the problem with this is, if it's a plus and I'm taking the last two items, then I don't need to convert them again, right? Because I know for sure that I appended an integer to my stack. So here's what I'll do instead. So I'll just say sum the sum the last two, right? So you say you know sum the score stack um -2 here, like this, right? This should work. Okay, something else is happening. What's going on? I'm probably doing something wrong. So there's a double plus here. Why is there a double plus? So if there's a double plus, it means we are adding. Yeah, I mean, we must have added. There must have been more items in the stack, right? I should have just coded this in my code editor before coming here. So let me use my playground here. I don't know. That was very slow for me, to be honest. Let me import the name, the class here, right? And then I'll say solution is equal to solution, like this, and print solution dot call points. So I'll take this first example. I'd solved this question before, so there's no way I'm getting this wrong. If I do, then it's fine. I mean, it's not the end of the world, right? So this is giving us 20, and our expected answer is 30. So let's see what we have in our score stack at the end of the day. So I'll print the score stack here to see what's inside. So we have 10 and 10, right? Is that what we are supposed to get? I mean, it's expecting 30, right? Yes. So we are supposed to do 5. So let me build the stack. Let me see the stack gradually as we iterate through the string. So I'll print this again. So we start with an empty stack. We added 5. Then we see a C. So we removed it. Then we have a 10. Sorry. So the 10 we have, right? We are not supposed to replace. I mean, I think the mistake is here, right? In the second iteration, we have a D, right? Oh, so I'm popping off the stack. I mean, so we have D. D is the fourth one. So after adding 5 and 2, right, we'll have 5, only just 5, and then when we see a D now, we'll add. Okay, I see what's happening here. Instead of doing pop, right, I'm supposed to take the last item instead. This is my mistake. Yes, and then do it this way. Yeah, now you can see it works. The conditions are validated. So I'll just submit this, right, and see what goes on. Yep, it works. 95% accuracy. Okay, so that's about it. I'm going to end the stream now.